Hello, this is Tim Stewart. I'm president at Visual Decisions, and we're here today to talk about the state of the art for the visual factory using Industry 4.0 and operational excellence. As a quick procedural note, if you have questions during the presentation, please enter them into the Q&A. I will get to them at the end of the webinar. Thank you. So the term visual factory refers to an approach in lean manufacturing processes and other manufacturing processes to put visual information throughout the workplace. Visual factory uses a system of communication tools to share information at the time and place it is needed. The goal for today is this: how can we improve visual controls so that we can see the real-time status of every process from anywhere? To achieve that goal will require change to how things are done in traditional manufacturing or even in lean manufacturing environments. By the end of the webinar, we should understand why this is beneficial and how to achieve that goal. To get started, we'll look at a few types of visual controls to narrow down our focus for the discussion. Then we'll look at the purpose of having visual controls and what they're meant to achieve. At a basic level, visual controls are meant to inform people of the status of an operation or to provide directions or instructions on expected behaviors. These goals can be achieved with simple controls, such as an and-on light, or static visuals, such as stop signs and walkways, or shadow boards displaying where to put different tools. These are absolutely fine for how the factory should be run. I mean, putting labels on bins and so forth is part of visual factory so that everybody understands exactly where things are supposed to be. But this isn't really the focus for today. These can go on exactly as they are. The next type of visual control is more process oriented. And these are things like SQDC IME boards, safety, quality, delivery, cost, inventory, manpower, and environment, production pitch tracking, job by job tracking, daily accountability boards, etc. There are pretty much endless examples of these different process controls, and I've just listed a few of them here. And each of the boards serves a different purpose. Some of them are meant to track whether the team is winning or losing on a given day, or how they're performing versus the plan. Some are meant for just basic tracking or information sharing. Others are used for planning purposes, but they all have a place in the factory. And when we look at these boards and we think about how manufacturing as a whole has really embraced technology and automation, on the left side we see augmented reality displays, we see robots and lasers and all these things that would have seemed futuristic not that long ago, really. And yet within continuous improvement, we're still using whiteboards and printed out Excel sheets that we're posting up places, and just very, very manual techniques. And that's not necessarily bad. But there are some problems with manual controls. And if we look at the process itself of maintaining the information on those boards, there's a lot of actual rework in that, because if you think about just going up there and updating those sheets on a continual basis, you're continually having to go there and basically do that same task. There's a lot of movement involved, different people coming and updating those boards and so forth. There are errors, there's missing data where people don't get out there to update their information. There's transcription errors. They might have counted wrong and so forth. This just really doesn't work in high volume environments where just the pace is too high to keep up with on a manual basis. There are a lot of limitations. Manual board is only viewable in one place. If you want to see that information, you have to go to the manual board. History or persistence, unless somebody is taking that information and copying it into Excel and then aggregating that information from different Excel worksheets, it's going to be lost when that whiteboard is erased at the end of the day. And then the level of detail is also lacking, and context of the information that's being captured is very, very weak. And so there are a number of different problems with manual controls. But if we look at traditional lean thought and so forth, or operational excellence thought, there's a great book. I love the book, Creating a Lean Culture by David Mann. Won the Shingo Prize, and it's fantastic for how you actually get the people involved in the process and so forth. And one of the chapters that he had on visual controls in that book talked about the advantage of the manual process versus what he called IT provided. Now, it's a little bit unfair because that book came out in the early 2000s, but it does run very much in line with a lot of the thinking of lean practitioners or operational excellence practitioners around the world today. And that you need to have these manual boards to keep people's fingerprints on the process, so to speak, is a phrase that I've heard before. That if you automate the data collection and so forth, that you lose that ownership and that feeling of involvement of the people. And then there's a variety of other issues that he lists here as being timely, accessible, precise, et cetera, that these IT systems are inflexible and so forth. And I think primarily what he was talking about at the time were ERP systems, SAP, Oracle, et cetera, and being able to generate reports from those to be able to display on the shop floor. And I would agree with him there. Yes, those systems are terrible for this purpose. But the way that the world has evolved, there are a lot more options than just reports from ERP system that you have to wait 6 months to get a change to from your IT department if you want to display something new. And so what we're going to do for a little bit here is to go through and look at essentially each one of those complaints from David Mann and talk about how we can address those with Industry 4.0 technologies. So in terms of the information being timely, from that traditional view, the IT system is going to be current as of the last report that was run, so to speak. Well, in Industry 4.0, we have the ability to put real-time displays out on the shop floor so that the information is being captured directly from the machine being displayed immediately. So it's actually much more timely than the manual data capture and so forth. Is the information accessible? And that traditional view was that the board is right there for everyone to see. You can see it from 10 feet or more away, and that the individual would only be able to see right in front of the computer screen. Well, today we can put that information up on those big screen TVs you see there in the background, and it can be seen from much further away than you can actually do on a whiteboard or any manual control. Is the information precise? And again, this was something that in the past was viewed as the information in the system was going to be precise regardless of how accurate it was. And what we can do today is we can actually make sure that that information that's coming directly from the machine controllers and everything else is going to be not only precise, but much more accurate than the information coming from people where they might, again, forget to go to the whiteboard. They might get busy. They might count wrong in the first place. They might, transcribe something incorrectly. There's a number of different reasons why the precision of the information is going to be better, as well as the accuracy of the information coming from these Industry 4.0 systems. And so because we have the ability to occasionally verify the accuracy of the data from these systems, as long as we do that on a periodic basis, we should have confidence that the information being displayed at any given time is accurate as well. Another question here is, does the data prompt questions. And in the past, looking at these ERP reports and so forth, it may not have had a lot of flexibility in how you analyze that information, what kind of questions you can ask, and really drive into that data. Whereas, it was viewed that the boards and so forth had the ability to, prompt a lot of questions from the people because they own that data, because they were putting it up on there and so forth. And where I look at that today with Industry 4.0 systems is that these not only display that high level information, but they're actually capturing the context of what was going on, in the plant at the time that that information was generated. And so you have the ability to actually display much more. You can put the basic display out there, but then it can be interactive so that the people can drill into that information, ask a lot of additional questions, and get answers right within that system. Easy to change and customize. And again, from the early 2000s point of view, it was if we need a new report, we've got to wait 6 months from IT to be able to see that. These Industry 4.0 systems, in many cases, especially if you're looking at something like an IoT platform, has the ability to have a user go in there and modify the mashups on a very easy basis. It's basically like if you can manage Excel spreadsheets, you can change the columns around and do everything that you need in a lot of these different systems. And so there are a lot of things that you can do that are just as easy in many cases as rearranging the tape and everything else on these whiteboards, or changing the Excel spreadsheets that you're then going to paste up on the boards in the plant. And for changes that go beyond that, then agile methodologies let you roll out a minimal viable product within a very short period of time and go through cycles of improvement on those that allow you to really quickly kind of adapt to changing needs in the plant. An intimidation factor. And I think that this was a valid point back in the early 2000s, but I think that that has largely gone away these days. I don't think people are really intimidated by screens nearly as much as they used to be. Everybody has a cell phone that they look at now, or just about everybody. And so people are very accustomed to gathering their information from computer screens, phone screens, et cetera. And I don't think that there's that same intimidation factor that there used to be. In addition to that, a lot of the manual controls make people do math, and that's going to be far more intimidating to a lot of people than actually just looking at information on a screen to figure out what they need to see. And so from an intimidation point of view, I believe pretty strongly that the screens that we can put out there today that are well designed and so forth are much less intimidating, much easier for people to absorb information from than some of these manual boards that have been put out in the past. Another question is ownership or alienation. And I've touched on this already, but it is a valid concern. I mean, people, going up and putting information onto these boards and so forth, they are involved in that process. They are collecting that data and so forth. But I question how much ownership is actually driven by just going up and writing a number on a board. For me, what really drives true ownership is how are the people utilizing the data that's there to actually drive improvements to the process? How are you creating positive feedback loops within your environment? And the real answer to that is the standard work. And the standard work has to be built not just around what am I, putting up on the display, but how am I using that information to really drive improvements to the process? Those are the things that are really going to drive that lasting ownership. Another point in that he actually gave credit to the IT portion on was information simultaneously available in many places, whereas the whiteboard can only be seen in front of the whiteboard. These dashboards that you have with Industry 4.0 can literally be viewed from anywhere in the world that has access to that network. And if you're pushing the information to the cloud, it's pretty much anywhere in the world, on your phone, on your tablet, on your computer, et cetera. And so you have that information that, if you want it, you can, have an alert come in at 2 a.m. and tell you that, some machine is down. And that has escalated to that point where you need to be notified. Now, personally, I would not want to get woken up in the middle of the night for that, but the capability is there. Computational accuracy, and this is again one of those places where math is not necessarily routine for a lot of the people on the shop floor, or heck, even engineers. We all make mistakes, but computers really don't. And so from a computational accuracy, these systems are going to be 100% accurate, every single time, assuming that they're coded correctly. But if they're not coded correctly, you will catch that during implementation or at the beginning, and they will remain correct afterwards. Overhead required. This is definitely one advantage of a whiteboard. It is cheaper. There's no question about that. But given all of the different advantages that we've talked about, there's a lot of value to investing in these Industry 4.0 systems, IIoT and so forth, that are going to be able to provide these real-time displays in a very flexible manner out on the shop floor, where you can create those positive feedback loops, drive the behaviors that you're looking for, and really get that return on investment for looking at those systems, as opposed to the traditional whiteboard type of approach. So some quick examples that I'll show today. I'm highlighting things coming from one of my partners, PTC, but I've worked with a broad number of companies that provide software that can do this across many different platforms. And so if I want to look at something like a KPI dashboard, somewhat of an equivalent to an SQDCM with a focus on whatever area you want, we can see screens that have a nice friendly display that are updated in real time. But the key that I want to show here is that you can start to drill into this information. So one of the questions that we looked at earlier was, does that information prompt questions, and can you actually access additional information with these systems? And the key is that you're able to not only see that top level information, but actually drill into that to be able to understand the details behind it. You're able to ask those questions and answer them in real time. So that can drive a lot deeper understanding for your people. Something like OEE is a very common, very important metric out in manufacturing these days. These systems can display not only what that overall OEE number is, but really what are the factors that are driving that performance. And again, this gives your people the ability to respond in real time to address those issues as they're coming up. And even going down further, looking at availability as one portion of OEE, now you have the ability to see, what are the reasons why the machine is stopping that are dropping your availability down. And by getting to this level, this is what's actually going to be actionable. So the data that we're capturing on whiteboards, where we had 6 quality issues in the past hour. Well, great. What were they? Why did they happen? What are the root causes for that performance and so forth? Those are the things that we need in order to take action. Just knowing that there were 6 exceptions doesn't really help us all that much. And so being able to capture the data at that level, have that rich context, and then being able to have the standard work to take action against this, that's what's going to drive improvements in the facilities. That's the real purpose of having this, the visual controls out there in the first place. And then for something like work instructions, being able to have, instead of a book that has, however many printed pages of work instructions and so forth, being able to have live connected work cells where the work instructions for whatever piece are in front of them are displayed, and they can track that information in real time. You can actually connect to the tooling and capture all that data automatically and so forth, instead of having people to write that down on paper or just have it be lost over time, is another huge advantage to being able to put these visual controls in place so that you can drive that standard work, so that you can have people actually run the process the same way. You can put a new worker out there and they can run the process like an established veteran. Next thing that is really coming and is actually here is augmented reality, and how can we utilize these augmented reality capabilities within the shop floor these days. And so kind of the key here is that this augmented reality capability helps us see things that we can't see with our naked eyes. I mean, that's the whole point of the augmented reality. And when we look at these different solutions, there are a lot of different applications out on the shop floor. And I'm just going to touch on a few today, but there are many, many more that are out there. And so if we look at some of these in terms of closed loop quality, error proofing, the work instructions, again, but even more enhanced and hands-free, are just really, really helpful for driving better quality and better performance within manufacturing. And so when we look at enhancing reality in the visual factory, something like this can help us really understand what is happening within the process. When we look at that machine with those glasses on, it can overlay information such that there's service required. Your autonomous maintenance task is due. There's a preventive maintenance task that's due, and you need to get maintenance over to perform that task and so forth. Something is overheating, and you should be paying attention to that particular motor, or whatever it might be. There's so much information that can be displayed with these types of capabilities that it's just really game-changing in terms of what you can do. Standard work, and how do you both communicate standard work and track deviations to standard work and so forth. And kind of the combination of the augmented reality plus the Internet of Things, and being able to pipe that Internet of Things information directly into the glasses and so forth makes it very easy to both communicate the standard work and then track how people are performing against that standard work as well. Augmented 3D visual controls. Sometimes this is just kind of a wow factor, but sometimes there are many additional things that you can do with these kind of augmented controls that you can't do with a physical control panel. And so in terms of the displays that you can put within there, being able to overlay alerts and understanding how the machine is working and so forth, you have those capabilities with the glasses that you just don't have with a flat screen or traditional displays. Closed loop quality. This is one example from Volvo that comes from PTC, where within the inspection process itself, the inspectors utilize these glasses to be able to see how things are supposed to look and then how they look in real life. And the glasses will highlight any discrepancies between the two. And so they can see whether the engine is assembled correctly, whether there are any missing parts, whether anything is outside of where it's supposed to be and so forth. And they can actually go through their individual steps very interactively to be able to see and check everything that they're supposed to in that checklist kind of a way. And then taking that one step further with error proofing as the process is performing, what we see here is traditional pick and place type of an operation, but the bins are actually being highlighted so that you can be sure that the people are picking the right parts and putting the right parts onto the assembly as you go along. And so these are the types of things that help ensure in challenging environments, that you're actually getting the right parts on the pieces to begin with. So those are a whole bunch of different possibilities, some additional use cases. From a digital management operating system perspective, some of the things that we talked about up front, daily accountability boards, production schedules, job-by-job tracking, the SQDC boards and so forth, TPM towers are another great example of things that you can actually digitize. A lot of these things can be put in place so that this becomes part of that digital environment and can be seen from anywhere in the factory, not just one central location. And you can share this information and drive the behaviors that you're looking for within your people. Setup support, something really simple that has made a huge difference in a lot of the customers that I've worked with, is a countdown clock. Setup is supposed to take 17 minutes, and you set a countdown clock so that when setup begins, it starts counting down from 17. And it's amazing how much that reduces the variation in the setup time. And so just something really simple like that can make a big difference. But having work instructions and other visual cues for the setup can make a big difference as well. Autonomous maintenance, when the operator shows up at their station, if you're driving that responsibility down to the operator, giving them the information that they need on a daily basis, where they show up to the station and it gives them an interactive list of, here are the autonomous maintenance tasks that you're supposed to perform today, and allow them to check them off as they go. Makes a huge difference. And you're giving them the support. If you're going to give them the responsibility and accountability, you should give them the support that they need. And then much more advanced things like live value stream mapping and being able to show in real time, what is my time at each task? What's the time between tasks? Where are the deviations to the standard flow? And so forth in a value stream mapping type of display can be very, very powerful, where that information is updated in real time instead of people just doing that in a one-time kind of a thing in a conference room. So some closing thoughts here. First of all, this is not meant to eliminate Gemba walks. You still need to go to where the work happens. It's just good that when you go to where the work happens, you have the information there instead of having to walk to a separate place to see the control tower that will display the information away from the actual workplace. Being able to see the real-time visibility to deviations from either the process or the expected results, and being able to take quick actions against those, is tremendously powerful to prevent issues from escalating over time. For everyone in the plant, they should have a real-time view of whether they're basically winning or losing that day. And having these displays out there can really drive the behaviors that you're looking for, so that you can make sure that all of your people are in a position to win every single day. And then finally, I've kind of hit these points throughout this presentation, so I won't go into details here, but putting the standard work in place to really utilize this information to improve the process and integrate it into the way that you do things every single day within the plant, and really change the culture to use this information and become a data-driven organization. That's how you maintain the fingerprints on the process. That's how you maintain the ownership, as opposed to people just going up and writing numbers on a whiteboard. So with that, that's the end of today's presentation. Some upcoming webinars that we have are listed here. Please go to my website at visualdecisions.com/events to actually register for any of these that you would like. Visual Decisions provides services and software from different partners in all of these different areas. Kind of primary is Industry 4.0 and Lean Six Sigma consulting services. But we also provide services around supply chain and forecasting and factory planning and data intelligence, business intelligence, et cetera. And finally, thank you very much. Please reach out to me at tim@visualdecisions or my phone number there if you have any questions or would like to have a conversation about how this can be applied within your environment. Thank you very much.